Hi, everybody. We're going to be doing inequalities. This is my second try at this. Hopefully I can get rid of the technical difficulties. We're looking at solving one-step linear inequalities using addition and subtraction. The good news is that inequalities, when we're dealing with addition and subtraction, behave just like equations in the way that we solve them. There is such a thing as the addition property of equality, but there's also the addition and subtraction property of inequality, and they work similarly. Anyway, let's get started. It's going to be fun. So, oops, try again. There we go. So let's see what our first one says. I'm also going to go into how to write some of the solutions in different ways. So this first one says that z plus 2 is less than 5. And I'm going to start with just a little bit of instruction on this. First of all, we are going to be using what we call the subtraction property of inequality. And if you want to know how to do it, we just simply subtract 2 from both sides. So z plus 2 is less than 5. And in order to solve this inequality, we're going to subtract 2 from both sides. And z is now by itself, and it is less than 3. We are allowed to do that, and that's the answer. Now, there's an infinite number of solutions that are less than 3, 2 and 1, but all the decimals are also included, and 0, and all of the negatives as well. If we'd like to see this on a number line, sorry, it's a funky looking number line. Here's our 0, and here's 1, 2, 3, and here's a -1 and a -2. And what we do is we sometimes think of this on a number line. Some people think, oh, well, it's going to be 2 and 1 and 0, but it includes all the points in between as well. So we have all these points. All these points are included, and they're all solutions to this problem. Now the trouble is that 2.9 and 3, it's going to be impossible to see the difference between 2.99 and 3 on a graph. And so what we do is we leave an open circle at 3 to indicate that 3 is removed from the solution set or is not included, and all the numbers less than 3 are included. Some books write this with a parenthesis, and the reason they do that is that there is such a thing as interval notation for solution sets. And if I were to write this in interval notation, the way I would write it is I would write the smallest number that can be the solution and the largest number that can be the solution. So in interval notation, this would look like -infinity, which is what's way out here on the end of this number line, all the way up to 3, and it's not included. That's what this little parenthesis means. For those of you who just want to do the problems and get it over with, it's just going to be z is less than 3. So let's move on to other problems and do a few more. Now, this one says r plus 2 is greater than 3. Subtract 2 from both sides and you're done. I mean, that's really all you have to do. But it's nice if you understand what's really happening here. It says r plus 2 is greater than 3, and we are going to subtract 2 from both sides, and we get r is greater than 1. I'm going to go ahead and write it in a graph. And all I'm going to do is include 0 and 1 and maybe 2. And it's an open circle at 1, and I want all the numbers bigger than 1. Again, another way to write that was with a parenthesis. And we could also include the interval notation, which starts at 1 and goes all the way to infinity. So all of these ways are ways in which to write the solution set of this inequality. The nice thing is that r could be 1.2, 1.5, 2, 5, 8, a million, a billion. It could be any number larger than 1. Now this time we have a little bit different situation. This little line under here means that k plus 1 could be exactly equal to 2 as well as less than 2. So when I subtract the 1 from both sides, which is correct, I'm going to have k is less than or equal to 1. So if we were to graph this situation, at 1 and less than 1 would be the solution. But I also, because of that equal sign on the bottom there, it could be equal to 1. And so we need to fill in that dot, which means that 1 is included. It's the only additional number that we're going to include in our solution set. Some textbooks and authors will use the bracket to indicate the closed filled in circle. Another way to write this is to go from negative infinity all the way up to 1 and included. That's why we use the bracket to indicate that it's included. If it was not included, then we would put the open parenthesis. Anyway, there it is. And of course, the answer is k is less than or equal to 1. I know, way too much information. We're going to subtract 7 from both sides and we're done. H is greater than or equal to 1. Some of you want to move right along here, so I'll get moving on it. In this one, we're going to subtract 2 from both sides, and we're going to get B is greater than or equal to 5. Yeah, this is easy now, right? We're going to subtract 8, and we're going to get negative 9, but we have Z is less than or equal to negative 9. In this one, D is less than 6. One thing I recommend that you try is try some of the graphs and maybe write the interval notation different ways. Z is, we're going to add 12 to both sides. I'll go ahead and write it out. Z minus 12 is greater than or equal to 4. And we're going to add 12 to both sides. And we get Z is greater than or equal to 16. So I'm doing the same type of problem. It's a lot like equations, but there is actually something else happening. We're keeping the inequality. So just keep that in mind, that it is slightly different than the rules for equations. I want to get lost while I'm doing these. We're going to add 18 to both sides and get S is less than 5. Going to subtract 5 and get Z is less than negative 8. And one more, looks like. We're going to add 3 to both sides and get P is less than negative 7. Be careful. Numbers that are less than negative 7 are numbers like negative 8, negative 9, negative 10. And it's easy to get those backwards. Remember that negative numbers look like they're going up and up even though they're going down in value. The reason is it's better to 07 than it is to 010 or 100 and so on. Closer to 0 is another way of thinking about the higher numbers. And in this, we're going to subtract 12 from both sides and get R is less than or equal to negative 19. This time, R could be negative 19 or negative 20 or negative 21 and so on. I'm going to write a really quick interval notation answer. It's going to be at negative 19, but it could also be less than negative 19. So this is my interval notation. My number line would look something like this. Here's 0, here's negative 20, here's negative 30. And we want it to be including negative 19 and everything this direction. So all of these numbers are the big negatives that are further from 0. Anyway, that's another way of looking at it. R is less than or equal to negative 19. Notice that I did include the little filled in circle. In this, we're going to add 20 to both sides, and we're going to get h is less than or equal to negative 38. And we're getting there. We're going to subtract 52 from both sides, and we're going to get c is greater than 8. And we are going to add 53 to both sides, and we're going to get m is greater than 31. Let's double check it. Yep, looks like that's right. What? Oh, greater than or equal to. Dang it. Gotta watch my inequality. Darn it. Okay. Well, it's nice if I do a mistake every once in a while, I guess. All right. I like this one because I'm going to write it out. Oops. Negative 23 is greater than or equal to u plus 51. Now, here's where you're going to have a little trouble because the u is on the wrong side of the inequality. So what I'm going to do is I'm going to go ahead and subtract the 51 from both sides, just like I do with the equations. Be careful, that is negative 74. Now, here's the problem. There are two ways to read this inequality. Excuse me. You can read it this direction, which says negative 74 is greater than or equal to u. But you can also read it the other direction, which says that u is less than or equal to negative 74. Now, you need to be able to read this both ways. And one way of thinking about it is that the arrow needs to be pointing at the same person or the same direction or the same side. This says, reading this direction, u is less than or equal to negative 74. Reading this direction, negative 74 is greater than or equal to u. And I can remember as a kid, I had a really hard time understanding that this could be read either way, because depending on which direction you read it. I'm going to go ahead and write it in the answer this way, but it's not wrong to write it this way. Either one is correct because they both represent the same inequality. So this is u is less than or equal to negative 74. Make sure I didn't make a mistake. Yeah, it's fine. In this one, we're going to add 83 to both sides and get j. Get rid of this. J is less than or equal to 84. And in this one, we get w is greater than or equal to, looks like we're going to have a negative 80, huh? Because I'm subtracting 19 from negative 61. And in this one, we're going to subtract 49 and get negative 24. So h is less than negative 24. Yep. And in this one, we're going to add 95 to both sides, and we get u is less than, looks like 64, huh? And that is probably okay. Yep. Please don't grab your calculator. It's a really bad habit to get into. I'm going to go ahead and write this one more time, this type. It is not wrong to write it the direction it's written in, but you do want to be able to read it correctly. Where it's really going to run into problems is when you do your graphs, because if you leave it like this, which is not wrong, I can leave it like this: z is greater than negative 80. It's fine. The problem is when you start drawing your graphs or writing your interval notation for the solutions, you're going to get them the wrong way, almost for sure. So a really good idea is to be able to rewrite it as z is greater than negative 80. And now, if you were to graph it, it'll be in the right direction. Let me just show you what I mean. Here's negative 40. Here's negative 80 out here. Okay, so look at this. And imagine trying to graph it on this graph here. This is representing z's, by the way. Sorry, it's a little, my proportion's a little off there. Anyway, hopefully you can see that this is really easy to graph and this is really difficult. It's going to be not included, but it's going to be greater than -80. Hopefully everybody can see that this answer is going to be much tougher to graph than this answer. I like the second one better. Of course, your interval notation would be starting at -80 and going all the way past 0, all the way up to positive infinity. And it's going to look like that. Anyway, I'm going to go ahead and write it in this first. I'm just going to write the -80. And I know some of you are going to want to do it that way, is less than z. And it's the same thing as z is greater than -80. In this one, we're going to add 30 to both sides. We're going to get b is less than or equal to 31. And looks like we're almost done. God, I hope this thing records well. This time we're going to add 941 to both sides. Looks like we're going to get c is greater than or equal to 992. They're giving me kind of easy numbers here to work with. It's nice. And let's see what the next one is. Looks like we're going to add 922 to both sides. This one's going to be a little more challenging, so I'm going to go ahead and write it out. It's -447. Again, a really bad idea is to grab your calculator. It's going to turn your brain off, kind of like when you speak. I'm going to add the 922. And notice I'm going to have a little bit of issues here. A lot of people are going to have trouble doing the subtraction in the order that I wrote it. So a good idea is to go ahead and write the 992 minus the 447 on the side. And then you can do your subtraction. It's a little easier. 7 from 12 is 5. Notice that I said 12 because I borrowed. 4 from 8 is 4, and 4 from 9 is 5. So it looks like it's going to be 545, and it is going to be positive. It's the positives win. Notice that it is best to take a difference when you have a larger number on top and a smaller number on the bottom. 545 is less than or equal to q. We can write it that way, or we can turn it around. I'm going to write it this way. 545 is less than or equal to q. What? Did I make a mistake? 475. Oh my God. Helps if I actually subtract correctly, doesn't it? Sorry about that, guys. All right. Well, let's see if I can do my subtraction correctly this time. That's part of the problem with talking while you're doing math, is that it tends to mess you up. Okay. I'm going to focus this time. -61. I'm going to subtract 61 from both sides, and I'm going to get Q of G is greater than 87, -87. So I'm just going to write it in that order. -87 is less than G. And I'm going to double check my work this time. Yeah. Oh, well, it's okay. You don't make mistakes, you never learn. S is less than or equal to -37. It does make you work a little harder though, and you do have to do a few extra. Okay, I'm going to add 553 to both sides, and I'm just going to do it in my head. C is less than, looks like 773. I'm going to take a look at it just to make sure. Oh, 783, duh. Always good to double check your work. Now it's right. That would have been unfortunate. I'm going to subtract 455 from both sides, and I can do it in my head. So I have T is greater than, and it's going to be a bigger negative, and it's going to be 989. And I'm just going to check my additions. 9, 8, 9. Yep, no borrows or even any carries, so it looks good. And let's see, we're going to add 661, and again, no carries. It's going to be an easy one. Greater than or equal to, make sure you get the right inequality in there. And we're going to add the 661, which is going to be 876. And it is positive, and I double checked my addition. Always good to do that. And we're going to subtract 13, not even a borrow here. We've got B is less than 800, and it looks like 82. And I'm going to add the 13 and get the 895. Yep. And we're going to subtract 771. This one's kind of interesting. We get R is greater than, this is going to be negative 1,000, huh? No, 800. Negative 800, because the 71 rounds up to 100, and I have negative 800, and looks right. And we're almost done. We're going to subtract 15. This is a nice, easy one because there's no borrowing, nothing difficult. It's just 1.85. No problems there. We're just subtracting 15 from both sides. In this one, we're going to add 7, and we're going to get S is less than negative. Looks like 2.6, and it looks good. And it looks like we are going to add 12.47 to both sides. Again, don't grab your calculator. 0.47 and 47 and 53 are what we call conjugates. And that means that when you add these together, you're just going to get 17. Trust me, it'll work. Take a look. Try it yourself. Actually write it out, I promise. It's going to be 17. If you grab your calculator, of course, it'll give you the right answer. It's just, it's better to practice with your conjugates so that you can add 12.47 with 4.53. And sure enough, you're going to get 17. And it looks like we've got 2 more. We're going to add 3 to both sides and get G is less than or equal to negative 1.97. Oh, point. Double check it, and it looks good. Yeah, less than or equal to. And we got one last one. Let's see if I can actually get the last one right. We're going to add 14 to both sides. And what you're going to end up with is 9.29. Now, a lot of people are going to go, wait a minute, you can't do that in your head. And you can. What I'm doing is using a thing called conjugates. And the 0.29 is the conjugate that goes with the 0.71. And basically what I'm doing is I'm treating this as if it's 5. And I'm subtracting 5 or adding 5, if you like. There's a bunch of things going on, but basically I'm using the idea of conjugates to make it easier. And so here's the actual work for it. 14 is less than negative 4.71, and I have to add 14 to both sides. Now, the reason I love conjugates so much is that if you were to do this by hand, a lot of people are going to have to do the following. They're going to have to write the 14, and they're going to have to write the minus 4.71, and then they're going to have to put the decimals in, and then they're going to have to borrow from the 4, and they're going to have to put the 10, and then they're going to borrow from the 10, put the 9, and put the 10, and yada, yada, yada. Now, what I did is in my head, I said, I'm basically going to take away 5, which gives me 9. That's what I did. I took away the 5, but I've got an extra 29 cents. So it's kind of like making change too. So this is going to be 9.29. Let's look at it over here. 1 from 10 is 9. 7 from 9 is 2. And 4 from 13 is 9. So conjugates are very powerful methodology for playing with your numbers and doing some arithmetic. People who do change a lot who used to do change in business would get very good with working with conjugates. And I'm going to make sure my answer is correct. Yeah, 9.29. And if I add it to the 4.71, I actually do get 14. And hopefully you guys will try it yourself and be able to get to mastery 2. Bye. See you next time.